Hello friends, welcome back to VSM Math tutorial. So in the last class we had discussed about Fourier series. Based on Fourier series we have done one problem. Today I am going to solve one more problem on Fourier series. So again very simple problem. Here we will do some extension part, that is deduction part. After obtaining the Fourier series we have to deduce some results. Okay. So let me take one simple example. Obtain Fourier series for the function Fourier series for f of x equal to x square in the interval minus pi to pi, and hence deduce that and hence deduce that 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus or minus etc. equal to pi square by 12. So this is very simple example with respect to Fourier expansion. So we'll do it. Okay. So how to go with the problem solution? First we have to write the required Fourier series in the standard form. So the required Fourier series in the standard form f of x equal to a naught by 2 summation n equal to 1 to infinity a n cos n pi x by L plus summation n equal to 1 to infinity bn sin n pi x by L. As I told in the last class also, there are two types of limits. One is 0 to 2L, another one is minus 2 plus L. So on comparison, so this limit is of the form minus L to plus L. Very clear picture. So clearly I will write L equal to what? Pi. L equal to pi. So if I substitute this L equal to pi, then I will get the required Fourier series for the given function f of x equal to x square. So that is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. Why? Because if I replace L equal to pi here, pi and pi will cancel, only cos nx. Summation n equal to 1 to infinity bn sin nx. So this is our required Fourier series for the given problem f of x equal to x square. Now we have to find out these Fourier coefficients a naught, an, bn using Euler's formula. So we'll go one by one. A naught. What is a naught formula? 1 by L integral minus pi to pi f of x dx. So this minus pi to pi they have given in the problem itself. So what is L also we know, that is 1 by pi integral minus pi to pi. What is f of x? F of x value is x square into dx. If I integrate x square, what happens it is x cube by 3 between the limit minus pi to pi. So that is equal to this 1 by pi, I will write as it is, and this 3 also I will write outside because constant. So if I operate x by pi, so it becomes pi cube minus pi cube, minus and this minus become plus pi cube. So it becomes 2 times pi cube divided by 3 pi. So here 1 pi cancel, so answer is 2 pi square by 3. This answer is nothing but a naught, but in the Fourier series I need a naught by 2, so that I will shift this 2 to left hand side, so it becomes a naught by 2 equal to pi square by 3. So this is our first Fourier coefficient, we have done it. Dear students, it is very simple concept. The only thing you should know how to integrate and how to apply the limits. Then we will move on to a n value. How to find out a n? Again formula, what it says, 1 by L integral minus pi to pi f of x cos mx dx. Actually it is cos n pi x by L into dx. Since we know L value equal to pi, therefore only cos n x will come there. So what happens it is n equal to 1 by pi integral minus pi to pi. What is f of x? X square cos nx dx. Now one is differentiable term, another one is integrable. This x square will eliminate or terminate after some time of differentiation. So we have to apply integration by parts method. That is, we know that u into v dx rule, that is u integral v dx minus u dash double integral v dx plus or minus etc. This we have to apply and we have to integrate. So here x is nothing, x square is nothing but u, cos n x is nothing but v. So what happens if I operate the parts method? 1 by pi x square as it is integration of cos nx dx minus x square differentiation is 2x double integration of cos nx dx minus 2x, that is plus 2. See, this minus and plus are formula terms, so don't differentiate it minus 2x. X square differentiation 2x, 2x differentiation 2, triple integration of cos nx dx. I stop the integration. Why? Because differentiation of 2 will be 0. So this is minus pi to pi. Now an equal to 1 by pi x square. What is cos nx integration? We know that cos ax integration is what? Plus sin ax divided by coefficient of x is a. So we have to apply that formula. In place of a we have n. So what happens? It is sin nx divided by n minus 2x into double integration of cos. See, one time integration we already had here. Okay, so we have to integrate this one more time. So sin integration is minus cos. So please be careful while integrating the function. In a hurry burry way, some students will write sin becomes plus cos. But in integration, sin integration is minus cos. So remember that. So one time cos nx integration is plus sin, then sin integration is what? Minus cos nx by n. That minus and this minus become plus. So what happens it is cos nx divided by n square plus 2 into triple integration of cos nx dx. See, one time integration of cos is minus sin nx, plus sin nx by n. Second time that integral, see, if you have any confusion you write like this, cos nx integration. So what happens it is sin nx by n. So its integration minus cos nx by n square. Again its integration minus as it is sin nx by n cube. Because every time when you integrate, you will have one n in the denominator. Okay. So its integration is what? Minus, I will write plus into minus sin nx by n cube between the limit minus pi to pi. Now whenever we have side terms with the limit 0 to pi or minus pi to pi, you no need to simplify the limits. Why? Because we know the standard result of sine. What is that standard result? Sin 0 value is 0, sin n pi value is 0. So that is the reason I can directly write the sin terms as 0, because the limits are pi and minus pi. Why? Because sin n pi is 0, minus sin n pi is also 0. Here also 0, here also. That's why no need to apply. So which are the limits we left now? n equal to 1 by pi. Thus 2 I will write outside and n square I will write outside. We left with x times cos nx minus pi to pi. 2 constant written outside, n square constant written outside, pi as it is, x cos nx. So if I operate the limits, so what happens? 2 by pi n square 2 pi n square. If you operate upper limit, x value is pi cos n pi. Pi cos n pi minus lower limit is what? Minus pi. Minus and this pi become plus pi. Cos of minus n pi, it become cos n pi only. Why? Because we know in trigonometry, cos of minus theta is plus cos theta only. Plus cos theta only. Therefore, an. So an value is what? 2 pi n square. So pi times, or else I'll see cos n pi value is minus 1 power n. This becomes 2 pi cos n pi. So it becomes 2 pi minus 1 power n. Why? Because cos n pi value is minus 1 power n. So pi cancel. So we left with the 2 into 2 4. So what is an value? 4 minus 1 power n divided by n square. So that is our an value. I hope you got it. It is very simple. Integration by parts. So one side I write, so a naught I know, an also I write. So what is an value? 4 minus 1 power n divided by n square. This is our an value. So now we have to find out bn value using the same procedure, but the formula is different. Okay. So very simple. So you can easily, but it needs practice. Dear students, you have to practice a lot. When you are looking the problem, when teacher is explaining the problem, it looks like simple. But without practice, if you go directly exam, so definitely it becomes difficult. So now I move on to Bn formula. Bn is 1 by L integral minus pi to pi f of x sin nx dx. So that is equal to 1 by pi, because L value is pi, minus pi to pi, f of x value is x square into sin nx dx. Again same, integration by parts by treating x square as u and sin nx as v. So by applying parts method, what we have? 1 by pi x square as it is, integral of sin nx dx minus x square differentiation is what? 2x into double integral of sin nx dx plus 2x differentiation to triple integral of sin nx dx. Stop here. Why? Because 2 differentiation is 0. So you no need to write that. Now, so Bn equal to, that is 1 by pi x square, integral of sin is minus cos nx divided by n minus 2x into, see one time integration we had here. What is that? Minus cos nx by n. If I integrate this one more time, so what happens? Minus will be as it is, cos become sin nx by n. So minus and this minus become plus, so that is sin nx divided by n square plus 2 into triple integral of sin. So just if you want, you have any confusion, you write like this. Sin integration is what? Minus cos nx by n. Next this integration is minus sin nx by n square. Next its integration is minus cos, minus into minus plus, so it is cos nx by n cube. So again I am getting plus cos only. So it becomes cos nx divided by n cube. So between the limit minus pi to pi. Again as usual I told, so when sin comes you can directly write 0. And since 2 terms are there, you can operate limit separately. So what happens now? Bn equal to 1 by pi outside the bracket. This minus 1 by n I write here. So x square cos nx minus pi to pi plus 2 by n cube cos nx minus pi to pi. This is another limit. So what happens? Bn equal to 1 by pi minus 1 by n. Upper limit is what? Pi square cos n pi. pi square cos n pi. Upper limit is pi square cos n pi minus lower limit minus pi whole square is plus pi square, cos of minus theta is plus cos theta, so that is again pi square cos n pi only. Okay, minus pi whole square is plus pi square and cos of minus n pi is plus cos n pi only, plus 2 pi n cube. So this upper limit is pi cos n pi minus lower limit is cos of minus n pi, again that is cos n pi only. So you can see here same terms but opposite sign, plus cos n pi into pi square minus cos n pi into pi square 0. This is also 0, so our bn value will be 0. So clearly bn should be 0. I hope you got this. So we have a0 value, we have an value, we have bn value, so we have to rewrite the Fourier series. Okay, so I just rewrite the Fourier series. Means I am substituting that all Fourier coefficient values in the given series expansion. So what is that given series? F of x equal to, so f of x equal to, what is our f of x? X square. So that is equal to a0 by 2. A0 by 2 value we got here. Pi square by 3. So write pi square by 3 plus an summation n equal to 1 to infinity. An value is what? 4 into minus 1 power n divided by n square cos nx. And no need to write bn into something. Why? Because bn is 0. We got it. So this is our required Fourier series expansion for the given function x square. Now from this expansion or from this series, we have to deduce the required result. You can see the result is in terms of numerics, numbers. So now how to take or how to convert this into numerics? Only substitution. For n I cannot take substitution because if I take n equal to something, I will get answer in terms of cost. But in the cost term is not there in the series. So only possibility is x I have to take substitution. Again, the standard angles between minus pi to pi is minus pi, 0, plus pi. Cos has value only for 0 and pi. Why? Because cos 0 is 1. Cos 180 we have value constant, but cos 90 is 0. So x equal to pi by 2 is not possible. Now the only possible x equal to 0 or x equal to pi. So x equal to minus pi also, cos of minus theta is plus cos theta. No need to take minus. You can take only pi. So I go with one substitution, that is let x equal to 0. Starting with x equal to 0. I'll check whether I am getting this or not. If I get this x equal to 0, stop. If I am not getting, then x equal to 0 is wrong substitution. We have to go for x equal to pi. Now, when you take x equal to 0, left hand side function is x square. X square is also 0. Pi square by 3. 4 is constant. I will write outside. N equal to 1 to infinity minus 1 power n divided by n square. It is cos 0. Cos 0 value is what? 1. So, minus pi square by 3, that is equal to 4 into, I am substituting this positive term to the left hand side, that becomes minus n equal to 1 to infinity minus 1 power n divided by n square. So 4 if I shift here, it becomes minus pi square by 4 into 3, 12. So that is equal to summation n equal to 1 to infinity minus 1 power n by n square. Now you keep on substituting the values of n here. So minus pi square by 12 equal to, if I take n equal to 1, minus 1 power 1 is minus 1, so minus 1 by 1 square. If you take n equal to 2, so it is 1 by 2 square. N equal to 3, minus 1 by 3 square. N equal to 4, plus 1 by 4 square, etc. It will continue. Since in the result we don't have negative sign, it is positive, so that I will take minus common on both sides. So what happens if I take negative term become positive term become negative term. Plus or minus etc. that is equal to pi square by 12. So this is our required result. So it's very simple. You can easily do it. The only thing, as I told, prerequisites are very important. That is integration. You should know properly. Okay. I hope you enjoyed this. So kindly share this video with your friends, those who are very much needed for Fourier series concepts. And kindly subscribe my channel, because your support is very important for me to do more and more videos. So I hope you enjoyed. So thank you all. We'll meet in the next class. Have a good day.